What's happening, my geometry peeps? Today we're talking about more parallel lines and angle bisector similarity. Alright, so two more theorems today. We're going to go over and do some more examples. Theorem 1. If three or more parallel lines intersect two transversals, then they divide the transversals proportionally. Alright, so if these three lines are parallel, alright, what happens is it cuts each transversal proportionally. Alright, so there's a few things we can set up here. Let's give ourselves some points of reference. A, B, so I'm naming each vertex. A, B, C, D, E, F, and we'll stop there. Alright, now if it cuts it into proportionally, again, the whole purpose is to be consistent, be consistent, be consistent. So I could set up a proportion, for instance, the length of this segment over the length of this segment. Top over bottom equals top over bottom. So the measure of AC over CE can equal BD over DF. Or you could go left over right, left over right. So I could go AC over BD is equal to CE over DF. Again, it's all about being consistent. So this went top over bottom. This went left to right, left over right. Alright, so whatever one you're comfortable with, that's fine. Just make sure you're consistent. Alright, so example 1. Find FE and BC given the diagram and the following information. So let's get our points of reference. A, B, C, D, E, F. Alright, we're going to say AF is 8. It says AE is 14, so we're talking about this whole piece. And it says CD is 12. And we want to find FE, so this piece and this piece. Alright, well, let's talk about FE. Now, it's saying the distance from A to E is 14. Well, if that's 8, that's 6. Alright, so now that we have that piece, we know FE is 6. We have a part of the problem done already. Now we can go into the rest of it. So we have top over bottom equals top over bottom. So 8 over 6 equals x over 12. So when we cross multiply, I get 6x is equal to 8 times 12 is 96. Divide both sides by 6, and x is 16. And they wanted BC, and BC is x, so that's 16. So that takes care of that piece. Now I do want to make a comment here. Let's say this wasn't 8 and you knew the whole thing was 14 and that was x, let's say. You can go top over whole equals top over whole. So in this case we could have went 8 over 14 is equal to x over x plus 12. So that situation may arise, and again, that's okay because it's divided proportionally and you're consistent. Top over whole, because the two small pieces are broken up proportionally, as are the wholes. Okay, the whole sides. So just keep that in mind if that conflict ever arises. Alright, the next theorem states, if there's an angle bisector in a triangle, then the intersected segments are proportional to the other side of the triangle. Say what? Alright, let's label this and explore a little. A, B, C, D. Alright, so what it's saying is if there's an angle bisector, so BD is a ray that bisects that angle, so we're saying ABD and CBD are congruent, then the intersected segments are proportional to the other side of the triangle. So this is the intersected segment, AD and DC, and they're saying it's proportional to the other sides, which is BA and AB. So pretty much like two pieces of this triangle are proportional to two pieces of this triangle if you cut it in half with an angle bisector. Alright, so it can look like this. You can go left over intersected piece, so side over piece equals the right side over the piece. And when I say piece, I mean the piece that's cut. Alright, the intersected piece. So you can go side over piece equals side over piece. Or you could even be consistent and go side over side equals piece over piece. As long as we went left side over right side equals left piece over right piece. So either proportion would work. Alright, again, this is the intersected side. Alright, so two more examples. We're going to say this is an angle bisector. This side is 10. This piece is x plus 2. This piece is 2x plus 1. And this piece is, or this side is 14, sorry. So set up your proportion. We have side over piece equals side over piece. Alright, cross multiply. So 20x plus 10 is equal to 14x plus 28. We should be getting pretty good at solving these proportions by now. Subtract 14 from both sides. Subtract 10. Divide by 6, and x is 3. So if the direction said solve for x, we'd be in good shape. If the direction said otherwise, find the length of each piece, we could put in 3, and we could find this to be 5, and this to be 7. And let's just examine this for a second. Is 5 to 10 as 7 is to 14? Yeah. When we reduce it, it'd be 1 to 2, 1 to 2. Or 2 to 1, 2 to 1. So you can always substitute in your x values and check your answers. If your proportions match out, you're in good shape. If they don't, you done messed up. Okay, let's come over here. And the directions are going to say find the measure of IG. And I'm going to call this MICHGA. We're going to say MI is 12, MH is 9, IC is 8, and GA is 27. And we're looking for IG, so I'm going to call that X. Okay, so we're going to say these lines are parallel as well. And this is an angle bisector. Alright, so now that we're all set up, we got to think, I see this triangle down here, right? I got that. I see that. But I have a problem. I only have an 8. I don't know this bottom piece, and I got an x or 27. So this bottom piece is key to me solving for x. So I'm going to need to find this piece first. Let's call that y. And if you cover up this piece here and just focus on the top, you can see we have an angle bisector problem. Alright, so we have side over piece equals side over piece. When we cross multiply, we get 12y equals 72. Divide by 12, and I'm sorry, y is 6. I don't know why I wrote x. Y is 6. Alright, so now we can cross out y and put a 6 there. And now we just look at the bottom triangle, and we have a parallel line there, so I can go top over bottom equals top. Top is 8. Top over bottom equals top over bottom. Top over bottom, top over bottom. It's just a little crooked. Cross multiply, 6x equals 8 times 27 is 216. Divide by 6, and x is 36. And that was IG. The measure of IG is 36. That's what we're looking for. 837 out.